Hi, welcome back to 8-Bit Resurgence. Today we're going to be doing part 3 of this video series where we're going to be taking one of the boards that I made and putting it into a case and testing it. So stay tuned and we'll get going with it. So today, as I said, we're going to be building one of these and testing it. So why this took me a little bit longer than I originally wanted to was because I wanted to use a different case. And so far you've seen an FDM printed case, you've seen a transparent resin case, you've seen a metal case, but I wanted something a little bit different. So what I did is I got in touch with PCBWay, who decided to help out with providing me with a different case. And this time I wanted to do a resin case, but I wanted it to be black, to kind of mirror the way the original FD drive looked. So this is the drive here, or the drive case, and it's printed in black resin and was provided to me for this project by PCBWay. The quality of the case is really nice. Like as with the transparent one that they did, the finish is really smooth, and it's very similar to what you would expect to see with injection molding. You don't see any of the lines. They've cleaned that up with their post-processing. Being a resin print, the resolution that they use is higher than I would with my FDM printer, just due to the nature of the ability of resin prints and how they work. And then they sand it down. Now there are some light scratch marks that you probably can't see on the video, but those could be buffed out if you wanted to. But overall, I mean, it's a really sharp looking case. I mean, I've already done some work already on this, just to speed things up so this video doesn't take too long. So I had put the label on the front and the back, and I popped the switch in already here, and I put feet on the bottom already. Now, one thing you need to be aware of when you purchase one of these from PCBWay is they do oil the case. I think it's oil. It's some sort of, perhaps part of the post-processing process that they follow, and you got to clean that off wherever you're going to put some adhesive. So the spots where you're going to put the feet, where you put the labels, you need to clean that off a little with some alcohol, and then the stickers will stick fine. I just wouldn't go over the entire case, because whatever they put on this resin, it does make it more black. So if you go over it with alcohol, it'll change the color slightly. So you just want to restrict your cleanup around where the labels are going to go. Otherwise, I mean, it has a nice smooth finish, and yeah, you just don't want to kind of mess up the look of your case by going too far with the alcohol and cleaning it up. So this is the case, and like I said, I've already prepared it a little bit. So we'll lift off the lid. The lid goes on the exact same way. It's got those little grooves here that hold the top of the front and back from moving. It stabilizes it. So we're going to put the board, I'm not going to go over the case anymore because I've already done that in the previous video. So I'll pull that out, the back there, the front comes out like that, but we don't need to take that out. I'll show you how easy that goes in and out. So then we're going to take the board. So move this aside a little for a second, and I'll show you the board. So this is the board that we're going to use. It's the FD-4000. You can see the large controller chip here, FD-4000 ROM, and 4 MHz CPU. And this one is the one that has the built-in RTC and the button cell, point cell built onto the board. So we'll bring this back in frame here. And to put the board in, it's quite simple. It just slides in, and then there are these ramps that I'd shown previously that it just runs up on. The only difference between this board, or how you'd set this board up and into a plastic case versus a metal one, is right here. You can see there's a heat sink, and on the metal case, this is a voltage regulator and it gets kind of hot. And on a metal case, that screws into a metal post that goes into the metal bottom, and that whole bottom part of the case behaves like a heat sink for that voltage regulator. Obviously in the plastic case we don't have that, so I just popped a little heat sink on there, and that'll dissipate heat for me. I did add that part number. It's a Mauser part, and I added that to the bill of materials, and you'll be able to find that there. So the board, it just slides in the back, and it just runs up that little ramp there. You know, pinch wires, and you pop it in place. Now when you're putting this board into the case, as you're positioning it to put the screws in, there and there, you want to push that swap button. That's this guy right here. And you want to push that and make sure that clicks while you're tightening the screws down. And because the adhesive behind that swap button, there's a hole there, and then your little momentary switch butts into that. Because it's still sticky, it can grab onto that switch, you know, and if you slide it over, it can depress the button there, and then once you screw it in, then the swap button is always pushed. So you just want to make sure that that button still clicks as you're screwing the board in place. So I've already put the screw in. I already put the screw in through the board and through the heatsink to hold it there so it wouldn't fall out during this video. So that's already there, so I can already screw that in, and then I just have the other screw to put in, and just like that. Push the board forward, make sure, yeah, I can still hear that, and then I just tighten this down, and same goes for this one. There, and that still clicks, so that part's done. The board's installed. It's nice and solid, and you can see the board's installed. You can hear that clicking. Everything is good there. The LEDs, if you can see that, the LEDs light up with holes, so that's nice. All those little things that you look at when you're assembling it. So then we have the back, and that's going to go on next. So before we pop the back on, while we have access to the 4 pins, those are the 4 pins there that for the power switch. It's only 2 are used. The other 2 are I leave there just to give it a more stable mount. And then that slides in, and that's in now. So as you can see, the back is now installed. The power switch works. I had already popped that in through the rectangular hole. The front looks good. So now we only have one thing left to do. In assembling drive, this is really straightforward, this drive. And today I'm using a TAC drive, FD-2000J 5670. So that's the drive I'm using, and if you can see, those are the jumper settings. I have included those in my build materials as well, close up to that, so you can see. And this is a 2.88 meg ED drive that you need for this type of installation. So we just have to attach the ribbon cable which is like that, and the power like that, and that's installed. So then I just fold the ribbon cable under the drive like that, and I set the drive in place. There are saddles built into the case, obviously. We've seen that before. And now we just have to put the 4 screws in to hold the drive in place. Hopefully that will extend it on its side. Where's that pop out? It will. I actually have to. Can't really do that on camera too well. Everything wants to fall out of my field of view, so I'll have to do it where I can see it and you possibly can't see it very well. So there's just 4 screws, and I'll probably just speed this up because putting screws in isn't a whole lot of fun to watch. All right, it's done now. So yeah, you saw I had to take 1 screw out, and that was because it had too thick of a head. I had grabbed the wrong one for that, so I had to get an additional shallow screw. They just have to be regular. The kind of screws that you use back in the 90s for floppy drives, they have a bit of a shoulder on them and they're quite shallow. Those ones work really well. You can probably get some. They're just M3 screws, probably 4mm, and just something with a shallow head. That'll work fine. So everything is installed now. We have a fully functional FD-4000 assembled into this resin case. So all that's left now is to put the lid on, and we'll do that. Now the lid, the vents are closer to the back than the front, so it'll go on like this. So it goes on like that. I'll just flip it over, and we'll speed this up for you again. That's just putting the 4 screws in the bottom. Okay, so that's it. The drive is now assembled, and I now have an FD-4000 reproduction, fully cased in a nice resin case. And last thing to do now is to test it and see how it works. So let's go over to the bench, and we'll hook it up to the 64, and we'll run it through a few tests. I plan on showing you how it can read various directories. We'll load some games. We'll try the swap button, and I'll show you how that works. And that'll be it for this video. It's actually going to be quite a short video. There isn't really that much. It's very simple to assemble, as you see, so let's get to it. All right, we're at the computer now, and here's the drive. We're gonna turn it on, we're gonna do some tests, and I'll narrate what I'm doing with the drive. You'll be able to see the screen because I'm capturing that as well. And you can see this drive that we just assembled functioning. So the first thing I'm gonna do is turn it on, of course. And I'm gonna check the drive channel, and there it shows you that it's DOS. CMD DOS version 1.4. So now this drive is an FD-4000, of course, that we built. So it is capable of reading 3 different formats. That's the 1581 format, the FD-2000 format, which is 1.6 megs, and the FD-4000, which is the ED, or extra density disk, that can hold 3.2 megabytes. So the first thing we'll do is we'll put a 1581 disk in that I'd already pre-formatted, and we'll do a directory of that. There you can see it's a 1581 disk, 3160 blocks free. So we'll remove that disk and we'll put the next one in, which is a 1.6 megabyte FD-2000, and we'll do a directory of that. And there, that's read that one. It's 1.6 meg high density, giving us 6,336 blocks free. And then this is an ED disk, extra density, and that one holds twice as much as the ED disk. So there you see 12,736 blocks free. So now let's put the FD utilities disk, it's just an original one that I have, and stick that in. The drive automatically recognizes the format and shows you what's on it. So let's have a look. Let's load the FD tools program. That's the program that allows you to manage partitions, format disks, and so forth. So I just loaded that. And there's that. So it recognizes the disk drive as device 10, and it recognizes the disk as a 1581 disk. This is the program that you actually use to change the real-time clock, to set the time. So this one I set long before the first video, and the time is spot on right now. The date is also correct. Everything is running smoothly with this real-time clock. It's keeping really good time. I'm going to just stop this because I don't want to change the time. But I also I wrote this little program, and this just gathers up the time through a little basic program and constantly displays it on the screen. So it just keeps running and updating the same spot on the screen, and it's kind of fun. It just shows you the running time. So that's usually, I use this little program to check the ARTC, but you can also do it with a Jiffy DOS command. And then it displays the time just once. It goes and grabs it and displays that for you. So that's working fine on this drive. I'm going to put a different disk in, and then we're going to try some other things. But the first thing I want to try out is the swap button. I want to demonstrate that. So right now, and I'm going to do that loading the directory old school. Right now the drive is set at 10, and I always set the drive as 10 because of the swap feature. It keeps it out of the way of other drives, and if I want it as a device 8, it's really easy to do, and I'll demonstrate how to do that. So if I do that, I can get a directory. That happens to be the directory on this disk, and I loaded it from 10, and that's how I have the switches set. But if I want this to be 8, I just have to press the swap button once, and that little activity light comes on briefly. Now that drive is drive 8. See, it's the same disk. Now if I want to change it to drive 9, I just press it twice, and then that light lights up briefly, and now the disk drive is drive 9. And if I want to return it back to the hardware configured setting, I just press it 3 times until both of these lights come on briefly, and now it's back to being device 10. So that's really handy if, for example, I'll demonstrate it with games here. Let's change directories to games, and we'll look at and there's, I'm going to pick Jumpman, And I'm picking that because it has many files in it. So it loads a lot of different files to start the game. But this game is designed to run on a disk drive with a device number of 8. Now, right now, this drive, as you saw just previously, is switched to be 10. And the swap feature isn't activated, so this is device 10. So if I load the first program on in this directory, oops, yeah, 8. I'm talking about 8. Okay, let's do it this way. I'm going to load this. Yeah, I should plan in advance, shouldn't I? Okay, so you can see that I got a load error, and I got a load error because this is drive 10. So it needs to be drive 8 for this game to load properly. So we can just press the swap button so that first light comes on. Now it's drive 8, and if I press a key, it says, because it's expecting the next file it wants to load to be device 8. So now that I had swapped it into device 8, it's going to load just fine. And there it is. And it loads pretty quick too with Jiffy DOS. So right now it's still device 8. We'll go back a directory, and then we can load a single file. So there's Blue Max. I know that that's a single file game. And that one has no problem. It could be 8, it could be 9, or it could be 10. So it's back at 10 right now, and that will load just fine and run because it only has to load the one file. So you see how you can manage the device numbers with this, and it can really be anything that you want it to be. So the swap feature is very, very handy. So I think that's really all. I mean, you can, I guess I could show you the partition management on the FD utilities as well. I could have gone into that before. So we'll do a directory of this this disk, and we'll load FD tools again. So in order, this is a 1581 disk, and it doesn't have any the ability to use partitions. That is a feature only available to the native formatted disks of the CMD. So we just changed the disk, but the program doesn't realize that we changed it, since we want to look at the partition management. So we're going to log a new disk. So I put the ED disk in, and now you can see it's a CMD 3.2 meg device 10. So you can go down to partitioning options, and you can view the partition table. You can do lots of different things. You can, so you see we have one partition, it's 12,800 blocks, and that is all the space on the disk. But if we wanted to do something different, we could delete that. We could delete that partition, and then we could do something different with this disk. All right, so I've deleted that partition. So now this is really an empty disk. It has no partitions. If I look at view the partition table, there won't be any entries on that. So now we can create our own partition. So let's create a partition, and we have different options. Since this is an ED disk, we can create any size and any type that's available to us. So this will be the first partition. We can say make that one a 1541 partition, and then we'll call that 1541 D1. You can call it anything you want. Yes, I want to add that. Yes, I want to create another partition. So then I'm going to create a 1571 partition. And you can see that's 1368 blocks. So this is a 1571 disk 2. But because we have so much space on this, we can have all sorts of different partitions. So let's make another partition. Let's make a 1581 partition on here. And we'll call that 1581 disk 3. And then we'll make one more, make another partition here. And we'll make that one a native partition. And we'll use up the rest of the blocks free that are on the disk. And I just did that by pressing the minus sign. That just kind of goes around the horn from the back side and gives you the highest number of blocks available. And then I'll just call this native. And no, I don't want to create. And yes, I want to write the partition. So now it's writing all those different partition table entries to the disk, and it's formatting the various partitions that we created, and that's done now. So now we could return to the main menu, and we could exit. Well, we can view the partition table. Let's do that. So let's read the partition table, and we'll see all the partitions that we created. So that's the whole disk. We have a 1541 partition, a 1571, an 81, and the remaining space we created a native partition. So let's exit out of here, and then we'll have a look and see how you access these things. So we're back to basic now, and we are currently looking at the first partition. That's where the drive drops you. So we have 1541 partition is just like a 1541. You have 664 blocks free, and that's it. Same block allocation map, everything. Now if we want to do say we stick this disk in and we don't know what what partitions are on there, we can do this command, and that will do a directory of all the partitions that are on there and what type it is. So there's a system that you can't access, and then there's the 1541 is the first, 71 is the second, 81 is the third, and native is the fourth. So if we want to look at partition 2, the command is change partition cp2, and then we can do a directory of that, and then now we're looking at the second partition. And if we change partition 3, now we're going to be looking at the 1581 partition, and we're going to change to the fourth now, and you're looking at a native partition. So each partition behaves like a separate disk, and you can organize your files, you can do whatever you like with it, and set it up however you want. If you just want all 1541 partitions on there because you got a lot of 1541 disks set up in a certain way, you can organize them that way on an ED disk or on an HD disk. You just won't have the same capacity. So I think that was the last thing that I wanted to show you. This drive obviously has a lot of capabilities, more than your average Commodore drive. And there's a lot of fun to be had from this thing. as you saw, once you have the board, very simple to assemble. The case allows for you to very easily affix the board to the inside and install the drive, close it up, and in no time you have a drive that looks very factory. I mean, I'm very, very pleased with the quality of the case that PCBWay made for me on this. Certainly it's one of my top cases. I really like the metal case, but this black resin printed case is phenomenal. It's smooth, it's sharp, it has some really decent heft to it, and it's a wonderful, wonderful print. And PCBWay did an awesome job, and I do have to thank them for providing this case to me for this project. It's really wonderful, and if you do find yourself looking to build one of these yourself, certainly consider one of these resin cases. They're just, you'll love it. So that's really the coverage demonstrating this drive. As you can see, it works nice. The real-time clock works nice, and it's going to be a really nice addition to my collection of drives for my 64, and I will absolutely use this regularly. So that concludes the third installment of this FD series recreation video trilogy, if you want to call it that. I hope you've enjoyed the process. Please do like and subscribe if you like what I'm doing here. Click the bell notification. You'll be notified of uploads. Thumbs up, thumbs down, all helps the algorithm. And leave comments down below if you have any questions or you want to see something different, whatever. I'll answer whatever I can. So thanks for watching to the end, and we'll see you next time on 8-Bit Resurgence. Bye for now.